basic work, IoT platform proposal design, implementation, evaluation, and conclusion. Go to part 1, introduction. In part 1, we will consider some points. Nowadays, IoT technology is very important because it has grown rapidly and applied to many fields. For example, smart city, healthcare, supply chain, industry, and agriculture. According to the estimate, there will be 75 billion devices IoT connected by 2025. There are many IoT protocols, but MQTT protocol is the most popular for IoT because it has the high transmission speed and this is a live protocol, so it's very suitable for the limited resource device. In addition, IoT network has many organizations with different way of managing user and different message structure, so it is very difficult to manage and exchange information between organizations. To address this problem, we propose the IoT platform which able to improve equity, security mechanism, and easy manage user and exchange information between organizations. We go to part 2, creative work. In part 2, we summarize some research paper how incremental add-on UOR protocol to enable access control in MQTT protocol. Benjamin Azi add-on UOR and introduce the concept of personal cloud middleware to manage user registration and IoT device. Rosie Kato add-on use Kafka message queue to as the sandbox system between MQTT broker and the rest of IoT system. This helps to improve the performance of the system and easily to scalability. And finally, Amos Hugo add-on combine Kafka message queue and MQTT for his intelligent transport system. We go to part 3, design of IoT platform. You can see figure 1 illustrate our architecture of IoT platform. Our architecture divides into two parts. Part 1 is system architecture. System architecture include two or many organizations. Each organization has the same component include the MQTT broker deploy a cluster with one broker for external communication and remain the broker for local communication. The single sign-on server, the single sign-on database, and the Kafka message queue. Part 2 is software architecture. Software architecture includes first, user are who use IoT service. Second, the thing is the physical device or application owned by the user. And finally, the channel is logical information for managing where users public message to thing, and the thing will supply to the channel to receive message. With software architecture, we will build the roll-up concept. That's only the user to send or receive message on his or her thing when those things are mapped to the channel owned by the user. You can see figure 2 illustrates the process of publish message between two organizations. This process will follow to this step. Step 1, user or publisher send the message to MQTT proxy instead of direct to the MQTT external broker. Each user process their channel, for example, the publish send message and the publish receive message. Each outgoing message has content OR token, and this token will be authenticated by single sign-on proxy. After authenticate user token, single sign-on proxy also check the user role. User role will involve to the permission of user. For example, this user is allowed to send message or only receive message, or is this user allowed to send message on this channel or not. After checking user validity and ground, message will be sent to the MQTT broker and finally reach the Kafka message queue. The receiver who authenticate and check user run by single sign-on proxy can receive message via MQTT proxy. To pack for implementation of IoT platform proposal, you can see figure 3 illustrate user organization apes model 3. In this model, we have three definitions, include root user, parent user, and child user. The root user plays the role as IoT network administration. The parent user can create, delete, or enable disable child user. Child user connect with the parent user via user parent ID attribute. If one user has started is disabled, his or her can interact to IoT platform. This helps with isolate the group of users or even organization from IoT network when the system is attacked. We go to part 5 evaluation. You can see figure 4 illustrate our evaluation model. Our model includes three components: organization 1, organization 2, and management central. We deploy this model on the several servers are listed in table 1. In organization 1, we have three components: one rocker for external communication, one rocker for internal communication, and API service. The organization 2 is similar to organization 1, and the management central include single sign-on server, database, and Kafka message queue. In scenario 1, we evaluate local communication ability with and without using IoT platform proposal. We simulate concurrent user who send message by using Zimeter software. Then we increase the number of CCU and record the highest number of CCU without system failure. The test results are illustrated in table 2, and we have the highest CCU with IoT platform is 400 and the highest CCU without IoT platform is 500. In scenario 2, we evaluate public communication between two organizations. Similar to scenario 1, we simulate user send message by using Zimeter software and record the highest CCU without system failure. The test results are shown in table 3, and we have the highest CCU without system failure is 140. We go to final part, conclusion. In this research, we try to reach some target. First, we improve the security of MQTT protocol. The second, we allow strict management of user, thing, and channel. The third, we allow to easy communicate between two or many organizations. And the final, our IoT proposal ensure don't lose message when connection is broken in comparison with MQTT protocol only because this protocol have no buffering mechanism. For the future research, we will consider brockerless architecture to avoid single failure point in comparison with brokering architecture using MQTT. And we also consider decentralized authentication. Thank you.
Thank you very much for presentation, for the interesting research that you have shared with us. Are there any questions related to the topic that was covered from the on-site participants? Okay, I don't see any hands raised. From the online participants, is someone who would like to ask the question? Also no question. So it means that the presentation was so good that was self-explainable. So thank you very much for your effort. And now we'll have some break until 2 p.m. where we will close the conference. So see you soon. Thank you very much.